We have a day 20 starter code. It's what we use from day 19, but I stole some stuff. Not stole, told Juan about it from his iterative delete hanging nodes. Speed up a little bit, added it in there. And here we are. So copy and paste that bad boy in. And I'll tell you what's new, and then we'll go look at it. I haven't looked at his shit yet. I wanted him here so I can make fun of him if it's fucking wrong.
It's pretty good.
It's pretty good. We did not have our search tree set to private. I had everything public. So I sold the get root, set root, and the delete tree. In the node class, we have delete hanging node, and he's got the destructor. His was get value for integers, but since we're doing people, I said get value, get first name. We could even make it a little bit better by doing some shit like this. Get value, get last name. That way it says the full name. So I've changed the destructor for the node. And then the real big change here is this delete hanging node. I'll give you a second to finish updating your node destructor if you want to make it cool like mine. If you're going on the NASA field trip, you should be getting that email today. I talked to them, and I know at least Austin from FNL, he got his already. So it should be today. If not today, tomorrow. Please fill it out right away. All right. So I want to say it was around 270. Line 270 is where I had the delete hanging node. All right. So we've got a deleting node function. Right away, he's using a this thing because this is a node method. So it has to have some way of referencing itself. Now, he didn't have to go with this equals null pointer. What is stored in a node? Node stores left and right. So if it doesn't even exist, yeah, I guess it does. And actually a good use for the case this. Gus. Gus is the little fat mouse on Cinderella, I think. I was about to say Sleeping Beauty, but she doesn't have mice. It's Cinderella. He's a cute little quirky little mouse. You've never seen Cinderella? It's not just for girls. Don't be a sexist bastard. Like Little Mermaid isn't just for girls. Ariel is hot. Just check her out. So fun fact, I should probably stop recording this, but I'm not going to. Fun fact, I used to work at the Diocese of Fresno as an accountant. This is the headquarters for the Catholic Church. The headquarters for the Catholic Church, at least in the Central Valley, is right next to San Joaquin Memorial High School, Catholic High School. So spring would roll around and fucking junior varsity and varsity team would run by and they're fucking short shorts, the volleyball players. And I knew it. And I wasn't looking or anything, but I noticed them one day. And I work with all women. And so I went and I sat down when I knew they were going to be running by. I just went to where the window was and I started talking to one of the employees, but the whole time I'm looking out the window. So they finally looked over and go, "What are you looking at?" I'm like, "Nothing." And they look and they're like, they just freaked out. They thought it's fucking great. It was great. They could be so sensitive. All right. So where's Juan? He's still not here. All right. So he's got delete hanging node. If this is a null pointer, return it. Else, node, make a new pointer. Forward is this. It feels like this should be. It looks like it's like supposed to be part of the binary search tree. Because why is it referencing? So we got this. Forward and previous are both the node that we're looking at. So maybe this sounds like this references other shit. I'm gonna get a camera out and draw a picture so we can follow along. Because y'all may be fucking super gifted, but I'm dumb as rocks. I need a picture. So we're gonna make a fucking picture. It's upside down. The resolution is shitty. And we need to do autofocus, which probably won't focus, so we're doing it. So what do we got here? This is working on, I assume, this was in the search tree area, so it's got to be related to that. Let's just draw some pictures of some nodes. Let's say this is D, B, A, and C. This goes down to F, E, and G. Let's picture what's going on here. So let's say we're looking at node B. We are at node B. So it's not null. So forward points to this and previous points to this. That's what 273 and 274 does. While previous is not null pointer, it's not. If forward is null pointer, which there's no way it could be, at least in the first loop. So the first loop, this is getting skipped. Okay, so if forward get left is a null pointer and forward get right is a null pointer, it's not doing that. So it skips this if loop. Else if forward get left So if forward get left exists, yeah, so we're here. So this would read a little bit clearer if it says it's not null pointer. If we're, you use null pointer for the rest. This I had to stop and think about what it's doing. Just adding in does not equal null pointer, clears it up. So for get left is not null pointer, and get left is A. It is not null pointer. Then previous equals forward. We're already there. And forward equals forward dot get left. So forward is here. So that one's done, and we skipped this one because we did the else, and we're going back up to the top of the while loop. If forward equals null pointer, no, it doesn't. So we're not on 276. If forward get left and forward get right are null pointer, which is where we're at. At A, both of those are null pointers. It deletes and sets the one you deleted to null pointer to take care of dangling pointers. So it says if previous dash get left equals forward, which it does. So line 282, we're under that criteria right now. We delete forward. And on previous, we set that to null. That's pretty nice. And that ends that if loop, because all the else's are else's, and that gets us down to here. And we already did this one, so we're back at the start of the while loop. If forward equals null pointer, it does. So forward equals this. This was the node we came in at, B. This came in at B. And so forward goes back to pointing at this. And we go through. 280 is not met anymore. Only one of them is null pointer. We don't meet the get left being not a null pointer. So we're here to the right. Previous equals forward, which it does already. And then forward equals forward dot get right, which is there. So now we have previous at B and forward at C. That ends that while loop. We come back around to the top. Previous is not null pointer. So if forward equals null pointer, it does not. If forward get left equals null pointer and forward get right equals null pointer, it does. Those are both null. We're in this one. We're in the 280 loop. So I'll open it back up so I can read it. If previous get left equals forward, it does not. Previous here, get left is null. So we're not there. We are on if previous get right equals forward. So we're on 287. We delete forward, which is C. We set forward to null. And previous, which is B, set right, gets set to null. So A, C, B, A and C are gone. That ends that loop. We come back up here to the top. Previous is not null pointer, okay. If forward is null pointer, it is. So forward comes back and points at B again. points at B, and previous is forward. So now we're back to here, but both nodes are dead. This is a different if. It's not an else if. So it doesn't go through the while loop again. It just starts here. And both forward, left, and right are null. If previous get left equals forward, it does. No. Previous get left does not equal forward. Right now, previous equals forward. The previous right, so we're here. We don't have previous is left forward or right forward. So we delete forward. And both of these are set to null. And that's where we started. We started at node B, and everything from node B onward died. So that was, this looks like it works. Do you guys follow that?
More or less, it's just memory deallocation for every situation.
Yeah, it's memory deallocation for every situation. But like just looking at the code, it's a lot. Draw a picture. If you're like working with new code, draw pictures if you can. See what's going on, follow along. It makes it like, I now know that this code works. I didn't start with D. I could have started with D. This would have taken longer. But I just wanted to illustrate how it worked. We'd started with D. It would have gone down to all the way down to A. Then it would have killed A. Then it would have killed C. Then it would have killed B. Gone up to D. Gone down and killed E. Killed G. Then F. Then D. So. And then he had the binary search tree, delete tree, get root, delete hanging node from root. Right. So this seems, the one thing I would say about this is this thing is deleting a whole bunch of other fucking nodes. Unrelated to the node it's in. I don't know if I would put that in node. I would probably just move this all as a thing into the binary search tree as part of delete tree.
If you look at report, you kind of do the same thing similar. You have like report on the node, and then if you look at the one where it's like print tree,
right?
You did that. You just did like a single function all the time. So I was like, oh, maybe this is the way that you want.
Right. The only reason I would say do it in the binary search tree rather than the node is report is just reporting. Node, delete hanging node is deleting other fucking things.
Yeah.
So like accessing and reading them is one thing, going and deleting, if it's someone else's shit, someone's gonna be pissed. So I would maybe move that part of the binary search tree. And all you would have to do is basically move the entire thing over here and say,
Instead of this,
it's just start off with this being get root. And then you wouldn't even need the this. But I guess if you are only wanting to delete part of the tree, there's a reason for it. I don't know. All right. So we read the code, we drew pictures for the code. We haven't implemented the code. So it was people, we had our people tree thing that we were doing. New line, fucker. Delete tree. And that's fun. I'm gonna put a space in there. Make it a little bit more readable. That's interesting. It did Dylan first. Oh, because it's based on the order they're entered in. The report doesn't show you the order that they're entered in. But it looks like they were all deleted. Let's see, we got 8 names. And 8 names got deleted. Fun, right? All right, what else do we want to do here? We did destructors. And we made brute private. Do a size method. Let's do a size method. So it's going to return an integer.
You want to do that.
What?
Limit the size, get size entry.
You want it shorter?
I mean, no, not get size, but like.
Find size? Get sounds like a get method, right? That's something we can decide on. So does size mean number of elements, number of nodes, or does it mean maximum depth?
If you do the amount of notes, then you just have to copy and paste the report, and then just instead of scouting, we can just count the plus one.
Right. So, and what does size do in vectors? Vector dot size reports the number of elements. So maybe let's make size do number of elements. And then maybe let's do instead of find depth, we'll do max depth. How deep is the tree? Okay. Let's copy these down there and put them down below. Where is my report? I want it in your report because I'm going to mimic report. And these are a binary search tree. I thought, did I put them in node?
Yeah, you put them in.
Okay. So why was it pissy? Do I need to do this? And say return. Let's say return 0 for now, so it quits being pissy. We'll say return 0 here for now too. So we're gonna mimic what report does. So I'm gonna go grab report. So maybe we need to start with make a new node pointer. Node pointer temp equals get root. And we need to have some counter going on. So we'll call it size counter. And now instead of doing left, now it's going to be if temp dot get left. You're right. No, because it's a recursive one. Oh, you're right. So if temp does not. Say it again. Right. Well, so the problem here is every time we do the report, even the recursive call, it's going to come back and right away see temp equals this. So it's doing the same thing over and over and over. And we don't want it to do that. Like in report, it doesn't. Each time it calls it, it goes down and does the next. If we did report here, report's going to come down and follow down to get E. It's going to report E, then it's going to go back up to F, come down to G, and each time it's starting with, every time it calls report, left out report right here, it's pretending that it starts at a new node. We kind of need that going on in the recursive format. So how are we going to do this? Yeah, we're gonna have to, but it might be what we need to do. But it's not appropriate for node. Like the size of a node should be 1, you know? Unless we did some shit and named it like you did. Hanging nodes, count hanging nodes. Why don't we do that? Why don't we make this a node thing? And rather than using the name size, I'm going to call it count hanging nodes. Because then I don't need that. And I'm going to go up and put this up top in nodes. And this is returning an integer. And I need to delete the size in that. And we might end up doing it with maxDepth too. What is it mad about now? Okay. So we can kind of steal like what we started with on the other node one. Where is it? If this equals null pointer. Actually, we got to think about how we're going to do this, because delete hanging node deletes them. And so like it makes it so it works. But if I try to just count them and not delete them, I want to do a count hanging node method.
Yeah, that should work with how we had it before for the report. For the how the report was originally. Yeah, but instead of using template methods, we do that. Under get value, you could say return, and then that's where you would do your. Instead of left dot report, it would be left dot counting from the notes.
True.
And then instead of counter, it would be return. Or not counter, return site counter.
Why?
One.
Oh, you're right. Each time it has to do. It's not return size counter. We want size counter to increment. We have to start it at 0. So let's first off, let's do this. Actually, let's do this. So what's going on here? Actually, no. That's not what's going on. It's definitely a separate thing. So let's draw pictorially what's going on.
Wait, it'd be not return site counter, but it would be left dot. It'd be return size counter plus left out. Nodes, so try to look at that. Okay.
Right, because this is actually returning something.
Yeah.
That's returning something.
So what you're trying to do is just have it catch all the yeah. Looking the left and the right separately. Yeah, but it's the return expression. If it was just one, it'd be really easy. Yeah. But it's the fact that it's the return of the two.
Is that gonna work? Look at a little nested thing, what's going on here? So we start off, we're in the D. So D, we can go left.
But every time it's returning zero. It's zero to zero.
So let's add +1.
Yeah. Okay. Yeah.
And maybe we should start at 1 for the top one. Okay, so we start at D. My size counter here is 1. And does if left, return. I don't want to return size counter in there. I just want to do if left, size counter plus left. Because it's only going to do one step and then it's going to return, it's going to break out. So if left exists, so now we go down to B, its size counter. So I'll say size B equals 1. It's got a left, it goes down to A, size A equals 1. It returns, so that goes up to here. And now size B equals 2. And then it goes right again from B. And it goes to C. So C has a size C of 1. Does it though? Hold on, when I returned left, I returned left size counter plus left counting hanging nodes +1. It was doing plus, so it added another one. That would have, I don't know that I need the +1 there. I think by changing size counter to 1, I compensated for that. I think we were skewing it. There we go. So size C equals 1. It gets added up to B. B is now, we're at size B equals 3. Size B gets returned, it's done. And it gets added to D. D now has, size D is 4. And it follows the right path. And does the same thing. I think that's gonna work. I think without a picture, that would have been fucking hard. So this comment about starting at root isn't even applicable. We need to do the +1 each time. And the first one accounts for the starting node, whatever node you're at. Let's give this a try. Where's my main? Okay, so we'll do a CO. Nope. Yep. Size of people tree. And now we want to do people tree dot get root dot count hanging nodes. And then an inline. I'm missing what? I got one. There we go. I'm like, why is it red? You took this class 20 years ago? Fuck, this class was a lot harder a long time ago. IDEs didn't show you your fucking errors all the time. You're programming this up on fucking notepad and shit. All right, I think it's gonna work. We counted them up earlier. There was 8 people in the tree. MFer. Oh, I think I know what was wrong. No, I don't. I don't understand why.
Oh, return size plus.
These ones are adjusting it and incrementing it each time. I like more verbose shit. I think it's more readable this way.
So what I mean is if left exists, what if right exists?
Right. See, this comes from being lazy and not doing that. And then thinking about it on 2 lines. Yeah. Very well, it could have just done plus equals. I think that'll fix it. Bam. All right, so I kind of like doing something similar. For the depth. So I'm gonna move this to the node. I'm gonna do max depth under node. So let's go up and move that up top. And we don't need it under search tree. Okay. Or down, where are we? Where is it at? Max depth, okay. I'm gonna copy this down. But instead of size count, I'm gonna go say max depth equals 1. And then I'm gonna have a temp 1 too. Instead of using size counter, temp equals plus equals. And then I'm going to say if temp is greater than max depth, for those of you online, Colin had to need a second for this. I think I kind of want to look at the picture while I'm doing this next thought pattern. So I had a max depth or depth equals 1. We have temp equals 1. So when I start at D here, D has both. Depth is 1, temp equals 1. Are you done, Colin? Okay. And so if left is not null pointer, temp plus equals left count hanging nodes. So we're diving into this. Left count hanging nodes goes to B. So we hit B. It has a max of 1. Temp is 1. And it goes to C or A. And it has max of 1, temp of 1. And here it's got no pointer for A. So A doesn't have anything here. It just returns 1. So we return temp. Let's make this temp. But what I want to do is track the max depth. So this is not helping here. It doesn't have the counts from the previous one. But we have a fine depth, don't we? That might be what we need, fine depth. So let's use fine depth here. So let's not do temp equals 1. Let's get rid of the temp. And we're going to say I'd return to it. Left just left do it. Okay. We're going to do fine depth. So that's my temp right there. And I probably don't need the temp. In fact, I could probably say max depth equals fine depth. Yeah. Max depth equals fine depth. But it's got to take in, it takes in something, doesn't it? Where is fine depth? Fine depth takes in, so it takes in this. Where am I? Fine depth this. Node is value P. Get value. All right, so if left doesn't equal no, left pointer, left max depth. I'm just gonna call it max D because max depth is the name of the overall function. And here we're gonna do max depth. So what do I want to do here? We've gone left, we're doing return max depth. No, that's not what I want. Left dot max depth returns a value. So int temp equals left dot max depth. And then we're gonna do an if. If temp is greater than max depth, maxd, return temp. Otherwise, we return maxd. And I think that's gonna work down here too. If I just copy this, paste this here, and change that to say right. Is it though?
You're gonna have a return max no matter what. That's just catching that the temp is greater, right? Like it's catching it like let's say max D is wrong. That's catching.
I don't think I want returns here. I didn't have returns up here. I want to say max D equals temp. And we'll get rid of that here. We'll put the same thing here. And then we just have the return outside of it. So at D, they're both 1 or 0. I think depth starts at 0. So I'll say 0. B has a depth of 1, but it's not down far enough. A has a depth of 2. And since neither of these trigger for A, the temp equaling 1, temp doesn't do shit. And it's just returning max D, which is 2. So it returns max D is 2 up here. So what am I having when I get back to B? That max depth here, that's here. So we're going in the B loop. This is saying temp equals 2. That changes that temp equals to 2. I'm going to add like C2 down here just so we can not do the full fucking tree. And so we do A goes back. We did A, B is max 2. And so that changes max to 2 right now. And then it goes right. Now we go right in B. We go to C. C has a max of 2. And it does temp equals right, which is C2, which has a max of 3. So it's going to return to 3, returns the 3. Temp comes up here is 3, max is 3, and it goes back up. I think that might work. Let's come up here and look at our person. Let's see what our structure looks like. So we start off adding me. So our structure that we're testing. FA is base node. Then we have Barry Allen, which is the flash. The flash is to the left. James Bond is to the right. Diana Princess is to the right. That's Wonder Woman. Diana Prince, not Princess. David Jones 125 is to the left. But it's to the right of Flash. And it's to the right of 007. So this is Hefe 25 down here. James Earl Jones is to the right of David Jones. So he comes this way, but he's younger than Princess or Wonder Woman. So Lord Vader is here. That's the voice of Darth Vader, James Earl Jones. Anita Jones is left of David Jones, Hefe 25. That was just a name that started with A. Let's see, Alan is to the left of Flash. Then he's to the right of the Barry Allen, or Dylan is lower than, or to the right of Barry. We get down to James Bond, it's to the right of James Bond. We get down to David Jones, he's to the left of David Jones. We get down to Anita Jones, he's to the left of David or Anita Jones, Dill Pickles down here. That's all 8 things. This is 0, 1, 2, 3, 4, 5. I think we're going to get a 5 when I run max depth. That's what, yeah, this is what should be returning. So I'll do this again. Max depth of people tree. Come on, come on, come on. No whammies, no whammies. Return 0. Well, now how is that fucking possible?
It means it's not counting it. It's like it's not.
It's not updating max depth. We got to do one final. No, we don't. This should be covering it. Right.
Wouldn't it always be zero?
No, because these lines are changing it. That changes max depth. This one changes max depth.
Oh, but and no point you add the temp or the next step, with next step.
What?
You never add the temp and next step. The next step is always. Like, no.
Temp is always doing find max depth. You know what? Let's try making them both start off as this. No, that's not doing it. Yeah, that'll work. Temp is still getting the value back from there. And if temp is greater than max depth, max D updates.
And they'll send you to the right as well.
Right.
So that catches the error.
Yeah, we weren't getting temp to do a max. Let's just run it.
So it's not the next.
I want to do a little see out of where we're at. What is my people thing? All right, let me try this. Hold on, person's got a way to report. I didn't go far enough up. Person is display. Now that will tell me who we're at.
More importantly,
And I'm gonna do C out max D equals max D. And temp equals temp. It's just gonna let me see What the fuck's going on? We're gonna do some error tracking right now. Gonna be a lot of shit on the screen. So it goes down to dill pickle. Is my tree wrong over here? Where's Dylan on my fucking tree? James Bond. Dylan is left of James Bond. Dylan is there. So we should have a max of 4. All right, so we get down to there. Why does temp equal 0? All right, so that helped us find our error. Value display, oh. Why is it saying Dylan has a max depth of 0? That's what, when it gets down to Dylan, it's saying he has a depth of 0. Which is not true. Wait, how does find depth work? Well, it's 6 o'clock. And we didn't get that solved yet. Either way, this was just bonus shit. So Wednesday, I'll have the test stuff up tomorrow, probably in the morning. Wednesday, there is no in-person component, but if you start working on your shit before then, and you got questions, I will be here on Wednesday. So you can bring in your shit and ask me, and that's not cheating at all. Asking your friends how to do it or how they did it is cheating. Googling how to do it, asking ChatGPT or Juan to do it is cheating. If you ask them related topics, that's fine. But like so on Wednesday, I'll be here to answer questions. If you got questions. I hope you guys like there's an announcement about it. There's gonna be two assignments, 2 labs. I don't think they're long, but they're as long as you want to make them. They're gonna be stuff that you should like. I'm thinking I'm gonna give you a choice to do topics about either music, television, or books. Everyone likes one of those. And if you don't like music, TV, or books, you're a boring motherfucker. Maybe I could throw in video games, but just give you an option. That way everyone's, whatever's your favorite thing to go with, roll with that. And then you'll do like a map related to that. And we'll do a binary search tree related to them. So it'll be something you're interested in. I'm thinking like if it's music, you could make a playlist. Well, no, it's gotta be, You're sending-
I mean, you said it.
Your map will be like maybe a playlist of happy music, playlist of study music. I don't know. I don't, you're just gonna like give me the names of the songs and artists. I'm not asking for the fucking like a YouTube link.
Or someone's gonna be a smart ass and send you an actual map.
Yep.
Like the Lord of the Rings map, and then like you like put the songs in.